seconds. Hello, welcome everybody to this week's Azure and AI Show. With us today we have Sweeta and Amy Diamond and myself, Frank Falvey. So we should have two other speakers with us shortly, but Sweeta is going to start this off, and I have her screen there now. We can see your screen there now. Modernizing core banking modular strategies that drive speed, saving, and stability. There you go. Over to you, so Sweeta.
Thank you, Frank. Thank you for giving me this opportunity. I am Sweta Lakkaraju. I have over 18 years of specialized experience in core banking systems with special expertise in SI systematics core banking product and Vision Plus a credit card processing product. I have extensive experience in core banking, core modernization banking initiatives, leading initiatives. I have worked on large-scale migration and conversion projects, and also I have worked on high availability production support, which directly aligns with my today's presentation, modernizing core banking modular strategies. Let's dive into it. So the first thing which we will be discussing about the core banking. Basically the core banking now is with legacy systems. So legacy systems are basically built on a monolithic architecture. So when a system is basically built on a monolithic architecture, our banks were built in such a way that they were like we go for branches to do our transactions. So that kind of focus was there when these legacy core banking systems were built. So they are on monolithic architecture. So because of that, transforming from a monolithic architecture to a digital to a core banking, it will have hurdles. It will have significant obstacles to transform into a digital transformations. So most of the platforms, most of these legacy platforms consumes IT resources in a huge manners. So as it is consuming so much of IT infrastructure and resources, which will restrict the innovations. Maintenance costs will be high, integrations will be very complex, and the change will be very slow. So this is what will happen with the financial institutions. They will find difficult to transform to modernization, and there will be a risk of they will be thinking that there will be a risk of disrupting the critical operations. So this is the challenge which we will face with the legacy core banking. So, and the risks included with the legacy core banking, if they do not move to core banking, will be this. First one will be the crippling resource drain, which I have already mentioned. Like the investment in the legacy systems will be more towards the IT infrastructure and resources. So what will happen is that critical funds will be invested in something which is not more reliable in the coming future, and because of that the top talent will move away from the vital innovations and strategic scalability issues. The next thing will be explosive integration complexity. This is also a big problem with the legacy core system. In this session I will call that as old system. This old system will have issues with external connections. It cannot easily do internal system upgrades or updates. So what will happen is when it wants to go for an external connection or an internal system updates with the old systems, there will be huge amount of custom data that needs to be developed by the developer teams. So if you are doing that much kind of development, that much amount is invested through that, so that will be rapidly accumulating the technical debt, and it will be a big huge barrier to the speed. The third risk which I'll be discussing is about the eroding competitive edge. As I told, the old system is very rigid. As it is monolithic, it is at one place. So what happens is it will be very slow on the pace of product innovations. So when it is not innovating anything, all the competitors in the market will have an edge over this, and it will attract the customers from the old system to the new era. The fourth thing is escalating regulatory risk. in this new era, what is happening is we are getting new evolving regulatory landscapes every day, you can say. So with the old systems, it is very difficult for the system to get acquainted to this revolving regulatory landscape. They cannot accommodate to this. So this will risk severe penalties and irreparable reputational damage to the financial institution which is using the legacy system. So in order to avoid this, we have to do the igniting the modular core revolution, which is something like financial institutions will be transforming from core banking systems from a monolithical platform to a modular platform using API driven architectures. So these innovative structures, what will it do is it will divide the complex functionalities of the system into smaller functionalities which can be independently deployable. And when you are which is independent and which is independently deployable, it will automatically increase the speed, flexibility and innovation of the system. So when we compare these monolith and microservices, monolith architectures are single tightly coupled systems. So if there is a change to the system, like if a service needs to be changed in that legacy system, then the whole system needs to be deployed. It cannot be deployed as parts. So when you're deploying the whole system, that's how the scaling goes. Like you have to scale the entire system, which is a duplicity. And then again, if you're doing this technology change for that system in that big entire system to a single service, there is also an issue with technologies, like you don't know where what if I change this, where it will affect, kind of things. So this change also causes ripples across the system. So and the main difference, these are the main hurdles, we can say the disadvantages the monolithic architecture has. So this approach, if we convert it into a modular architecture, these are the things which will be handling it. So here we will be building independent loosely coupled services. So as we are building loosely coupled services, that they are be granular and incremental updates, and every specific service will have its own scaling. And there will be a technology flexibility because we are doing on single services. As these are independent services, if there is any issues or there is an impact, we can just isolate these changes and revert it back. So this is the main advantage of modular architecture. So these are the core principles of modular banking system. So these are the 4 things which are more needed and which serves as the pillar for the modular banking systems. The first one is API first design. These are like every capability will be exposed through well defined documented APIs, which enables seamless integration with internal systems, third party vendors and fintech partners. This will be like an open connected system or a network which will connect with everything, rather than like a closed system which our old system is. The next will be a domain driven design. Domain driven designs are something like if you have a functionality as a service, that service itself will be considered as a domain and you will develop it as a service. Like in a bank, domains can be payments, lendings, accounts, rather than the technical categories of it. So this will directly align with your technical architecture and your business in a reality. So that will enable the teams. Like if I will take 10 people for development of accounts domain, I will take 10 people for development of payments domain. So the work will be distributed and teams will be able to work independently instead of waiting for other teams to complete something and do this kind of things. The next is cloud native infrastructures. So cloud native infrastructure is designed for these systems because it can grow or shrink whenever needed to support the DevOps practices. Uh, it enables rapid deployments, like you can do in continuous deployments. It enables specific automatic scalings, and it also improves the disaster recovery capabilities. The next thing is security by design. When we are talking about security in this core modular system itself, we are breaking down each and every service. So every service will have its own security at every layer, and with zero trust principles and end-to-end encryption and comprehensive audit trails. So modular architecture enables more granular security controls and faster the threat responses. So to achieve this core modernization things, we need a strategy, and that strategy is called strangler pattern phased migration strategy. This is a proven approach, which is a low risk approach to core modernization actually, because as I told, the legacy systems are big systems which are tightly coupled. We have to break them down, do it in the pieces, and we have to do it in the phase, every phase. So it will be phase wise migration, and you will by doing this, what will happen is you will not touch the system stability. The system stability will be maintained as usual until this migration is done phase by phase. So in this strategy, it needs 4 stages. First stage is identify and isolate. So in your legacy system, you will identify a service which you think can be modernized, and it is easy to modernize and less complex. We will choose those things first to modernize and experience modernization. So once we identify, okay, I found a service, I will try to modernize this because it is less complex and I know what all it needs to be done. So when I go for the development team, and development teams will have to build the service which meets all the functional and non-functional requirements, which is same as in the legacy system. Whatever the services, whatever the scope and limitations of that service is there in that legacy system, that needs to be implemented in this new service which we are doing for the modernization, and then it should be deployed. Once it is deployed, that deployment will be parallel to the legacy. It is not like we will close down that service in the legacy and we will run this service. No, this service will be running parallel with the legacy and going down after some time. Yes, when we think this new service is stable, we will route the traffic from legacy system to the new service to check its performance and behavior, and we will validate how it works with the real world data. So when we think yes, it is running with the real world data also with is fine and it's not causing any issues, we will move on to the next stage saying retire and repeat. We will retire the legacy service which it has in the legacy system, and then we will implement this new service directly. So the direct new world data will directly come to this new service, and new service will serve that purpose as legacy system was doing. And the customer will not know that he is using a new service until this legacy system is been completely modernized, and there will be no disruptions to the customer things. So once we are done with that retire, we will repeat this process again. We will identify one more service, we will try to see what we can do that, and we will follow the whole cycle again and again until the whole system is converted to the core modernization system. Benefits of this approach is reduced risk. As we are doing in independent services, it is minimizing the potential risk itself. Like even if it is failing, we will have only this single service to roll back, and it is very simpler to roll back than the entire platform replacement. The second is continuous value delivery. So you will be delivering every service in a in a month or bi-weekly or something, like uh, whatever is aligned with your project, your timelines. So that will be like with every delivery, the management will be seeing that there is something is being added to the system, and that will each migration will add the immediate capability to the system, improving the agility and reducing the technical debt. Next, the learning and adaptation. So when in the legacy system, to do a change, the developer or the technical team has to know the entire system. But when you are moving to the core modernization, and if they are working on a single service, that single service will be easy for a person to know in and out of the system. They will know what are the scopes and limitations of the system, how it should be behaving with what kind of data. And when they are moving to the core modernization, that core modernization platform will require new tools, new platforms. So they will also be learning some new things which will contribute to their learning platforms. So this, with every migration, they will have something to improve, and this will also improve the savings and quality over time. And the next is business continuity. As we are not retiring the legacy system at one go, we are doing it in phases. It will not disrupt any critical operations, and customer will also not know there is any service degradation, and the regulatory compliance will also be intact with the system.
Sorry, Sweeta, do
Yeah.
you have slides for the other pieces? Are you moving on those slides? We just have the main slide. Yeah. Okay, that's cool.
Okay.
Yeah.
You see it? Okay.
Yeah, perfect. Yeah.
So the next thing is domain driven design in banking. So domain driven design in banking is nothing but architectural blueprint for modular banking systems, where you will identify few domains in a banking system. For example, in a bank, I can identify customer as a domain, account as a domain, payment as a domain, lending as a domain. And a customer domain will have his IDs listed, his KYC information, his preferences, his relationships with other domains. Like a customer can have multiple accounts, a customer can have multiple payments, he does multiple payments, can have a lending a loan account. So these are all the relationships he will hold with the bank within the account and customer domain. So this will all be interrelated, and this each domain will have its own functionality. So in domain, I will choose one domain as a service and implement that service an individual and independent service. So this will establish clear boundaries between domains and enabling independent development and deployment while maintaining data consistency and business rule integrity. Next, moving on to compliance. We have to ensure compliance also when we are doing this strategic things and modernization migrations. So when we have to adhere to the compliance, and we have to implement our core modernization techniques. So the biggest advantages with compliance in this core modernization techniques will be, we will have granular audit trails for each and every service. As we have isolated services, there will be isolated regulatory controls by every domain. It will be faster to adapt to new requirements. It will improve the data governance and lineage. It enhances security and access controls. And next, the critical considerations for a compliant system would be, you have to see how the data is residing and how the sovereignty requirements are there in the system. You have to see how the transaction is consistently flowing across the services, and you should have a monitoring and logging of each and every input and output data which is going and being served. You have to have a regulatory reporting aggregation and change management and validation things which are needed for the compliance consideration. The next thing is building blocks of integration excellence. This is nothing but the API driven architecture kind of thing, which will have API gateway, which will serve as a centralized entry point, managing authentication, rate limiting, routing, and protocol translation things. The event bus will serve as is a asynchronous messaging system backbone, which enables real-time communication with between the services. And service mesh will be like an infrastructure layer, which will be handling service to service communication, observability, and resilience. The next will be the data platform stage, where it is used for unified analytics and reporting layer, aggregating data across all the dates. Like you will be generating reports depending on the business requirements. The next thing is achieving agility at scale. So when we are moving to the modern architecture, how financial institutions, it is basically how financial institutions respond to the market opportunities and competitive threats. So when we are leaving behind the monolithic systems and when we are moving to independent services, it should give you the agility. So there are three factors for that. That is accelerated time to market. Because your services are independent, you will be able to launch new products in weeks rather than like in bigger timelines like quarters and half yearlies. And you will, as it is an independent service deployment, it will eliminate coordination bottlenecks. The second thing is safe experimentation. As the service is individual, you can go for testing without risking any core banking operations. Like I want to test something on this service, I will test it and it will be easy for me, and it will not interrupt any regular core banking operation things. The next is elastic scaling. As we are doing scaling on each and every specific service, the scaling will also accommodate according to the demand. So this will optimize the infrastructure costs while maintaining the performance of the system. The next is reducing complexity through modularity. The whole point of core modernization itself is we are breaking down the complex modules into the smaller individual and independent things. So when this happens, as I told earlier, we should have clear explicit contracts. Like each service becomes independently comprehensible, testable and maintainable. So when we are doing this testing, the teams which are involving in this testing or development or design of the system will have deep knowledge about the service. Instead of learning the whole system, they will know the service, about the service in and out. So that will itself reduce the load of the team, and which will improve to development velocity and the system reliability. So the key complexity reduction mechanisms here will be bounded context, limit the scope of understanding required. API contracts make dependencies explicit and versioned. Independent deployments eliminate coordination overheads. Technology diversity allows fit for purpose solutions. So the foundation for this sustained innovation is like when we are moving to core banking architectures, it emerges over time. Like you will be able to see the speed gains, the savings, the quality over with each passing year. So here the four things which we need, which will which are is in this cycle are very important are experimentation, because each and every service is individual. There will be low risk testing for the new capabilities and business models. In ecosystem, when an API comes into the picture, it will enhance the UI capability of the system, and which will attract partners and enriches the customer value. As the API system is an open network, it will connect through the services, so it will be easy, and will be an eco-friendly system. The learning, as I told, like there will be they will be doing in the phases and stages. There will be a lot of feedback about the products, architectural designs, decisions. So there will be a lot of improvement, like okay, this thing was not captured or being not covered in that last migration, let me cover that in this thing, kind of thing. The next is scaling. So successful innovations deployed broadly with minimal friction. So like when we are doing the individual components, anyways the scaling will be aligned to only that specific services. So if anything is disrupt, that service will not disturb any other service. So that will be a minimal friction. So this whole cycle itself is a competitive weapon which enables financial institutions to adapt continuously evolving customer expectations and market dynamics. The last slide will be the takeaways from this session. The key takeaways is modular architecture unlocks speed while reducing risk through incremental transformation. The strangler pattern provides a proven roadmap for phased legacy migrations. Domain-driven design ensures technical architectures reflect business reality. compliance strengthens rather than weakens. With the proper modular design, long-term innovation acceleration creates sustainable competitive advantage. But the next steps which we need to follow to go to a core modernization would be, you have to be able to assess current architecture and identify the modernization capabilities or candidates needed for that, and build cross-functional teams with business and technical expertise. Select initial domain for strangler pattern implementation. Establish API governance and design standards. Create feedback loops for continuous learning and adaptation. Thank you.
That was a very good, interesting presentation, Sweeta.
Thank you. Thank you.
I don't see any questions coming in. If Raj, have you any questions? Let me see, he's on mute. But is the core banking, is that stored in-house, or do you use the cloud as well?
You're saying about the core banking system. The core banking system is stored in mainframes. Actually, that is why we call it as a legacy system. And these are the huge systems which are maintained on a high-level cost, like maintenance.
So you wouldn't contemplate a kind of a hybrid model, whereas you would have some stuff
now that banks have adapted to this core modernization techniques. Now banks are moving to these modernization layers because they want to invest more into the front end services kind of thing. So now this core modernization mechanism started implementing. That is the reason why most of the banks through here, the FIS, ANZ, SBI, these banks are now moving their services to core banking solutions in phases. Like you cannot migrate a legacy system directly to a core. It will at least take for you to do a 2 to 5 year span to do the whole system core modernization. That would be a positive transformation.
Yeah.
So while doing the modernization, they will go to cloud initiatives and they will have to adapt. So that is the reason why there will be a lot of learning for the core system guys to do this modernization parts.
Yeah, very complex, as you were explaining there earlier.
Yes.
Yeah, very good. Yeah, interesting times ahead. And will AI help to speed up this modernization, or
correct,
would the governance wouldn't allow it, maybe because of the core banking?
Yeah, it will take time because banks deals with your personal identifiable information. So everything, if anything goes wrong, your whole data will be out in the world. So yes, now banks are emerging with AI. They are taking security measures. They are starting to get into these things. But yes, it's happening now. Like from last 2 years, I have been seeing this migration and conversion projects taking a boom into the system mainframe, like bank systems, like with the Citibank or BMO Bank. It's going in a fast-paced thing. So like whatever project comes in will come with that aim, like how I can modernize this part of the service and how it will go with the next future conversions.
Very good. Very interesting.
Yeah.
Watch the space, as they say. Raj, can you hear me there? Yeah, very good.
Yeah, I don't have any questions, but great presentation, Shweta.
Thank you, Rajesh.
Rajesh, do you want to share your screen there with us? And this will kind of tie in with Sweeta's kind of what she was talking about there. You'll be kind of talking more about the data side of things.
Yes.
Yes, very good. So when you go to present your screen, yeah, I can see it there now. We have it there, yeah. Building a unified medallion architecture in Microsoft Fabric.
Perfect. Good afternoon, Frank and everyone. Thank you for joining me today. Today, I will show how the medallion architecture pattern on how we can implement it on Microsoft Fabric. Some of the steps is landing the raw data in the lake house and how we standardize it and model it for gold layer. And I will end with a live demo. So before we get into the aspects of today's discussion, I just want to quickly give a quick intro about myself. I'm Rajesh Vayala, a principal data architect working at a global data recovery company where I led the enterprise cloud data warehouse modernization on Microsoft Fabric. I have more than a decade of experience working across different industries such as finance, marketing, logistics, and nonprofits. I'm much specialized in enterprise data architecture and data modeling and building cloud native data platforms to support the reporting, analytics, and AI ready use cases. Um, on my free time, I'm actually contributing in industry forums, doing speaking engagements, working with the different editorial boards for any technical reviews, and also attending and presenting conference papers at technical conferences. So let's get into the agenda. So first, I'll go and discuss about what is medallion data architecture and what are the different layers within the architecture, and then we'll look at the live demo. My topic is data chaos to clarity. So for imagine if you're like walking into a massive library where all the shelves packed with books, but with no catalog or no sections or no librarians and no rules. You might find what you need eventually, but it would be incredibly frustrating, inefficient and error prone. So that's how many organizations operate with the data today. So they have collected large volumes of data, but there is no clear system to organize it, manage it, or ensure the right people um, can access it when they need it. So that's where, like, the concept of data democratization came. It's more about solving this by giving people the ability to access the right data safely and efficiently while still maintaining structure and governance. So it's not about making data available, it's about creating clarity out of chaos with the right tools, guardrails, and shared understanding in place. um, so some of the examples where data chaos occurs is where there are fragmented systems and pipelines, inconsistent definitions and duplications, and it creates slow time to insight, and with a lack of governance and lineage, as well as difficulty in scaling for new sources. So in this picture, you can see, like, if there is in the past, like we used to have these legacy data warehouses where they were built for control. And on the right side, you can see the today's platform that are built for change with cloud native solutions, where the decoupled compute and storage and ELT, we have entered a more flexible era, so on the left side, where if you see it's a tightly coupled legacy system where it's static and brittle. These are the monolithic ETL pipelines where we have rigid schemas with limited scalability, and any schema changes or business logic update break multiple downstream reports. And it's mostly batch based, delays for any insights by hours or even days. And these legacy used custom SQL scripts and ETL tools like Informatica, Data Stage, and so on and so forth. And there are legacy systems, these were like IT owned black boxes. If someone from a business side or data side want to access this, it's very hard to get access. And these legacy systems were built for stability. Whereas if you look at the left side, the modern architecture, where it's a more layered, modular, and cloud native, where the medallion architecture, especially, it supports, the three-layered architecture where we have bronze, silver, and gold, oftentimes like raw, clean, and curated data, or each organization have their own way of naming these different layers. But the idea is to have a decoupled compute and storage where it allows for elastic scalability on demand. and where this architecture, it supports both real-time and batch, and integrates easily for any data science or AI ready use cases. And we can also use other tool stacks like DBT, Spark, Delta Lake, notebooks, and semantic models for any reporting or transformation or integration. And it will also enable for smoother collaboration for our data analysts, data scientists, and data engineers in the shared environments. So if you want to broadly talk about the three different layers, before we get into why Medallion architecture. So the first thing is it organizes data. Um, and it can help to build the quality and trust. So by deliberately keeping the raw data in the bronze layer, we always have a copy of the raw data from different sources, and then we clean and standardize this data in the silver layer, where we check for like any data types, dedupes, and business keys. So by the time the data reaches a gold layer, it is business ready and explainable. And the second one is like a stepwise refinement, makes any testing easier. If a metric looks off, we can check gold logic, then the silver, and then fall back to the bronze. Each layer has a clear contract, so no issues are isolated quickly. And then the third one is reusability and consistency. The shared silver layer acts like a trusted foundation. So multiple teams can reuse the same conformed entities like customer, account, and product, without rebuilding the same transformations, which eliminates any duplication and drift. And as I said, the scalability, when we onboard new sources, we land them in the bronze layer and then extend silver mapping without breaking down the downstream reports or analytical pipelines or ML pipelines. And the gold models and reports keep working, because their input, the confirmed entities remain stable. And separating the raw, standardized, and curated layers provide a clear lineage for auditing, and where the data governance policies, classifications, and approvals can be applied at the right stage, which simplifies the compliance and sign-offs. And performance is key, where the gold layer delivers the optimized and curated data sets, where we can have like star schemas built on the tables and summary tables and semantic models. So the analytics and ML pipelines run fast, with smaller joins, and where we keep heavy lifting upstream and serve thin purpose built artifacts to consumer. Finally, I said in the previous slide on the collaboration of having the data at the silver layer, or within these three different layers, each team or the data engineers and data scientists and analysts can work confidently of the trusted gold data, and everyone moves faster because the responsibilities are clear, the data is reliable, and the changes or propagated predictably throughout these layers. Um, so let's look at the progressive refinement of the pipelines. So if we look at the bronze layer, which is a raw layer, it preserves the fidelity. Here we ingest the data exactly as is from any cloud storage or on-prem or different federated sources. It append only, and where we retain the full history. We do minimal validations and mostly envelope checks, and store drift prone fields as a string or variant or binary. So schema changes do not drop the records. Every file or record gets provenance metadata like load timestamp or ingest ID or metadata file name and source system. So bronze is the single source of truth and our safety net for audits and reprocessing. And this is not for like any analyst to come and look at the data if they're looking for any aggregations. So if you look at the silver, it's more like clean, validated, conformed, standardized. So this is where we enforce the quality and make data reliable for broad use. We read from bronze. And clean and deduplicate, do the typecasting or hand in nulls or like any out of order data, and normalize or flatten the structures. For example, if you want to look like where you can combine the customers and transaction data and create a customer transactions after dropping any nulls, or quarantining any like invalid rows or fixing types or keys for any predictive analytics. Or in the second example is like where you can create accounts plus opportunities from Salesforce and create account opportunities where it's enriched with account attributes, So the Silver should keep at least one validated, non-aggregated representation of each record. Heavy aggregates are usually belong in the gold layer, so the silver layer avoid writing to directly from the ingestion, so that risks failure on schema. They would always stage in the bronze first. So now the final layer is a gold, where it's a business ready curated data, and gold layer delivers semantically meaningful performance optimized data sets, and we align to business logic and a dimensional design and publish just the shapes or the business need, where if the as an example, where if the business users want to look at the customer spending, like average versus total spend per customer, or the daily KPIs per account to look at the account performance. So goal may be split by domains. In one of the company, like where I implemented Medallion, we kind of created these domains within the silver layer itself, to keep the ownership and access clean. And some companies they do this at the gold layer, just to make sure that the ownership and the access are very clean. And so this is the layer where like all the data scientists, the analysts, and business users come and hit to query the data. So why this Medallion architecture matters is that these layers give us the trust, and where the operational safety and consistency and reuse without breaking any downstreams, and this will enable us to move from a ingestion chaos to trusted data products, So some of the key takeaways is that Fabric, Microsoft Fabric, this turns the Medallion layer architecture practice on one lake, and the direct lake delivers the speed without duplication, and you can also use Microsoft Purview and consistent security, and you can also enable your AI use cases using the Microsoft AI products. I would like to do a demo. Let me stop sharing the screen and then reshare it again. So please bear with me.
Yeah, we got it there now, Rajit.
Are you seeing the Fabric right
Yeah.
now?
Welcome to Fabric, yeah.
Okay, perfect. So now we are in the Microsoft Fabric environment, So if you look at the left pan, where you can see the different options to where you can go to the workspaces, and then you can look at the co-pilot option is there, and there is a one layer catalog, and there is monitoring and real time options, and there are different workloads. And if you have like any workspaces, you can just look at the workspaces. And here, workspace. So workspace in a plain terminology, it's more about a project that you are creating, kind of thing, So what Fabric has done is that if I select a new workspace, I can just create a workspace with the name and all. But one helpful thing to implement the Medallion architecture is that the Microsoft created some pre-designed templates that are called as task flows. And if you look at it, there is a Medallion task flow here. So what basically it does is like, whatever that we discussed in the earlier PowerPoint presentation context, where you can create the ETL pipelines or data ingestion pipelines to source the data from your on-prem or file-based systems, and then you store the data in a bronze layer, and then the prepare is where you're pulling the data from bronze, and then you are doing the transformations and loading the data into a silver layer, and then this prepared data is again a aggregation of data from silver layer to the gold layer, and in the end you can create Power BI reports, or you can just analyze and train data using some data science pipelines. We can do that, so there are different item types that they call. So what are these item types is like where you can use a copy job activity to load the data, or you can use a lake house or a warehouse to store the data. And there are other data transformation things, like you can use notebooks or you can use data flow gen 2, and there are dashboards for Power BI analytics, so I'm going to just select a medallion right now, just to show how the flow is, and then yeah. So here, if I select a medallion, so this is how it shows, like, so as I said, like, there is option for you to select the low volume data as well as high volume data. And if you click at a new item, where you will be able to select the different options, the items that are recommended for this particular task, where you can use a copy job activity or an event stream or a pipeline. And then for the bronze data, for me, the option it is giving is to select a lake house, but however, you can also use a warehouse if you want to, or you can use a SQL database, or a Cosmos DB to store your data. And then again, for the initial process, you can use a Spark job or a data flow gen 2 or a notebook to transform the data. And then for the silver data, again, you can use a lake house or a warehouse, so for my project, what I'm basically doing is that I create a warehouse, sorry, a workspace, and I will gonna select a lake house inside it, and then I'm gonna show my demo, so let me just open my notes, and then use, so first we will do is like we will start by landing 3 data sets in the bronze layer, and then transform them into the clean and structured silver delta tables, and finally produce a business ready gold table using Spark. So we will do all inside a single lake house, as I said, like, the medallion, task flow, it will enable you to create multiple lake houses for each layer. However, here for my demo, I'm just using single lake house to do this, and this will show how Fabric simplifies like end-to-end data engineering while keeping everything governed and performance optimized. So let me just create a new workspace, where I'm gonna just say it like demo. So I created a new workspace. Okay, so inside this workspace, I'm gonna add a new item, and I'm gonna select this as a medallion lake house. I'm gonna save this one or create this one. So now that you have a lake house that we successfully created, where you have options of tables and files. Currently, we don't have any tables and files. So what I'm gonna do for my bronze layer is that I have three files like customer, account, and transactions. So I'm gonna create a subfolder under the files that I call it as bronze, and then once I have the folder, I'm gonna use the get data option and upload the files. So I'm gonna upload these files. So here in the bronze layer, we land data, raw data exactly as it comes in. So no transformations or no business logic. I have uploaded three CSV files that represent customer accounts transactions, and the bronze is our system of record and full fidelity, full auditable. So everything downstream built on this raw data foundation. So in this second step, what I do is like I'm gonna I'm gonna go to the lake house, and I'm gonna open a notebook, which is a new notebook. Um, so this notebook is attached to the Medallion Lake House. That's good. So I will use a Spark notebook to process the files from the bronze layer. Because the notebook is attached to the lake house, I can read both the files and table sections directly, and we don't need like any external connections needed. So the first step that what I do in my notebook is that so before we start transforming the data, I'm listing the contents of the lakehouse files area. So you can see the bronze folder, and inside it, our three files. This confirms the Spark can see the same files. So yeah, these are the files. So this means that Spark can also see that the same files that we uploaded through the Fabric environment. So let me so first so, so the bronze layer, it shows three different files of what we loaded or what we have seen. And at the second step, that what I'm gonna do is to read the bronze CSV files. For that, read. Yeah, so here you can see the data from our customer file, which is having the customer ID, the customer name, the last name, the email ID, and the account file and the transaction file. So at this time, we are just loading the bronze CSV into the Spark, and the data is still raw. The strings are untyped, the dates are text, and casing is inconsistent, which is exactly what we expect for the files to look at in the bronze layer. And now that we have the files, so now we can do the silver layer transformations. So the first step that what we can do is um, to sorry. So to transform our customer file and display the records. So for the silver customers, I'm applying business friendly cleaning, where we are standardizing the name casing, and where we are lower casing the email, and converting date of birth into real the date type and normalizing the country and state code. So Silver is where data becomes trusted, the typed and analytical ready. Let me also quickly clean the account.
Layer where it will format the data according to the downstream applications, or is just a transforming and adding business logic layer, like how the silver layer is being used?
Sorry, do we have a question?
Yeah.
Uh,
Hello, can you
yeah,
hear me?
yeah, I can hear you.
Yeah, Rajesh, in silver layer, it's about cleaning data and adding the business logic and all, right? So, do we do the formatting of data according to the downstream application files? What do we do in silver layer particularly? Do we do any formatting, or do we have any business logic additions in this layer?
I mean, so we standardize the data, right? So silver layer is where, like, if the data is coming from, let's say, if a customer account is coming from, or customer file is coming from 3 or 4 different sources. Each source have a different way of managing the data, right? So that's where, like, we bring the all the data from all these sources, and then standardize it based upon the business rules that what the team has agreed upon working with the data governance team.
So all these things which are coming from like different files will go into one file for that one downstream application, right?
No, the downstream is more in the gold layer, right?
Oh,
So the gold layer is where we create the star schemas or the aggregated tables for the reports or data science or analytics use cases. Where silver is, I'm creating a standardized data sets. It can be used for n number of downstream the reports or applications.
so okay, the application interaction will come into the gold layer.
Gold
Okay.
layer, exactly.
Yeah. Okay. Got it. Thank you.
Sure. So now that I created 3 different codes, to clean the account data and also to clean the transactions. So, and you can see some of the changes that what we have done. So now in the silver layer, I want to write this cleaned data as a delta tables. So in this step, what I'm gonna do is, like, I'm gonna write the silver as delta tables. So delta gives us the ACID transactions, where we can enforce the schema, where it is excellent for performance and where it integrations across Spark and SQL. These silver tables from the are the foundation for our gold analytics. So once these are created, we can go into this table section, and we will be able to see the tables that are created. The job is still running here. Yeah. So before we didn't have like any silver or like any tables. At least now that we have like a silver account, silver transactions, and silver customers table. So now in this step, what I want to use, like, I want to use the same tables. So what I would like to do is, like, I would like to build the gold layer. For the gold layer, I'm starting from the key clean governed silver tables. And this will ensure the consistency across all downstream consumers. So what I would like to do is, like, I would like to reload the silver layers in these steps. So what I'm gonna just do is, like, I'm gonna reload these silver tables. And then I'm gonna join these 3 silver tables. So this join ties like every transaction to an account and then every account back to the customer. So this fully integrated data set is ideal for like building customer level insights, so in this step, I'm gonna join these three silver tables. And once this is done, I would like to create a unified data set into a gold level customer summary. So for each customer, we calculate the total amount spent, the number of transactions, the last transaction date, and this gold table, it answers like any business questions directly and are perfect for reporting and AI. So now that you have seen here in the output data set, we have the customer ID, the account ID, and the transaction ID, which is a unified data set, a join of all the three silver tables, So now aggregate to create uh, gold customer summary table. Yes, so now you can see the total amount spent or the transaction count or the last transaction date, So everything is in our gold summary, gold customer summary. And what I would like to do is like I would like to save the final gold output as a delta table called the gold customer summary. And this gold table is now visible in the lake house. It will become visible and it will be ready for our Power BI for semantic modeling. So save save delta table. Just creating one table. Yes. So if I can refresh these tables again. So now that you have seen a gold table, so I don't want to verify. So that the table is still available. The table is available. So what you can do is like you can basically use that table and you can create the Power BI semantic models for your data. Sorry, for your reports. So that it will be used for any reporting and analytics. So did it answer your questions, whether you are asking about like where we create um,
Formatted files.
yeah, formatted files? Yeah. I basically created everything in one lake house, but there are organizations that have like humongous data, so they might create a number of lake houses um, for their data management, or as I showed earlier, where you can also create a medallion task flow, and you can create a lake house or warehouse. So one of the use case of in my previous company, what we have done is like we have used lake house for bronze and silver, and we have used warehouse for the gold layer. That's where we can create these task schemas for our Power BI analytics. So that's one of the use cases that what we worked upon.
Okay, nice.
Yeah. Any other questions, Frank? Okay, I'm gonna stop sharing my screen.
Yeah, sorry, I was on mute there. Do you know you had a slide earlier where you showed the bronze, silver, and the gold? So, like the bronze one would only have connection to a small amount of resources, and then if you go up to the silver one, you get more resources. So, does it go on price, or do you have to use the 3 layers?
So the earlier options that what I showed, are you talking about the fabric side of things, or you're talking about the presentation?
Yeah, the fabric side of
Yeah.
things.
So within the fabric, see, within the medallion task flow, you can use any of the items that are associated for a given task. For example, if you're using uh, if you're using the bronze level items, so I don't believe it's a task. I mean, it's not for pricing. At least we haven't seen any pricing related options for each task.
Okay, no problem. Brilliant presentation, and it is grand to see live demos and they work at the end. Very good.
Yeah, thank you so much.
Any
For
other?
any further questions, you can use my email or you can reach out to me on LinkedIn, and I'm happy to have any discussions.
Yeah. So this is available on LinkedIn Live, and it's also on my YouTube channel. So thanks, guys, for joining us this evening, and sweet and great presentation as well, you. And I'll send you on some more information about the MVP program as well. And okay, just going to end the live show. Thank you, everybody, for joining us today. And we'll be back here again next week at the same time with 3 new speakers. And we have Stephen saying well done there to us. How you doing, Stephen? Thank you. So back here again next week, 3 new speakers. And there you are. The presenters did very well. Okay, very good.